Hello guys, so I'm here to explain about NAND and NOR as universal gates. If you don't know about NAND and NOR gates, just check other videos in YouTube and get back to here. So let's see how NAND and NOR are universal gates. As the universal gate definition itself says that the gate should implement all kind of basic gates using itself. Like for example, okay, let me start with NOT gate. You already know that if you give A to the NOT gate, it returns A bar as output. So using NAND gate, if you want to implement this NOT gate, as we know that NAND gate requires two inputs. So if you observe carefully, it gives A bar as output when you give A as input, because see, A is going from here and here also A is going, so it will return, the NAND gate returns. If you give A B, the NAND gate returns A B bar. You know that it gives negation of AND. So we have given A two times, so it will be A to A, and we know that A dot A is A, because dot operator works as intersection. So the intersection between A and A will be A itself, right? So it is again A bar. So that's how we got A bar here. So we proved that NAND gate can act as NOT gate. And if we want to implement AND gate, let's take A B. Here it returns AB bar. So what we have to do? We have to get AB, because AND returns A into B. We already know that we can implement NOT gate using NAND gate. So we are going to use this NOT gate here. Same AB as input again, and then it returns AB, because it's already AB bar and now it is AB. So we implemented AND gate using NAND gate. So this is just basics. Then I'll give you a short trick, like I'll explain everything, like all gates using NAND and NOR gates. Before that, let me just give you a memory tip to remember how many NAND gates are required to implement all kind of gates, and how many NOR gates are required to implement all kind of gates. So if you observe, just remember or note this table. That's it. You can easily remember. This table is also very easy. What we have to remember is the order of these gates. The order is NOT and then OR, exclusive OR, exclusive NOR, NAND and NOR. Just remember this. So when I explain how we implement all these gates using NAND and NOR, you'll get to know how we are going to use this number of gates. You already know that we used only one NAND gate to implement NOT gate, so it is 1. And to implement AND gates using NAND gates, we require 2 NAND gates. For R, 3, and this is 4 and this is 5. Simple, right? So you just need to remember this order. Then here you need one NOT gate to implement NOR gate. To implement NOT gate using NOR gate, and from here you just take cross. So this means you need 4 NOR gates to implement XNOR gate, 5 NOR gates to implement XOR gates, like that. And here, of course, to implement NAND itself, you need only one NAND gate, right? And this is again 4, and this is 4, and this is 1. This is the table you have to remember for sure. then only like it will be easy for you to remember. So let me just explain how to implement these all gates using this number of gates and this number of NOR gates. Let's start in fresh page. Try to memorize the tip that I have told, like the order here. We know, right? NOT gate and then AND gate and then OR gate, XOR gate. XOR means next it will come XNOR, obvious, right? And then NAND gate and NOR gate. Simple, right? Yeah. So then I've already explained you how to implement NOT gate using NAND. This returns A bar, and here also it is quite similar. We'll get A and A bar. And AND gate. This is also I've told you before. Very easy. I'm sorry. You can actually take A and B. Then you'll get AB bar, and here you'll get AB, right? Then first, let's focus on NAND gate. Then we'll go to NOR gate in next stage. To implement OR gate using NAND, take A and also B, because we know that this gives output as A plus B, right? So we need two inputs for final output to get produced. So again, I already told you 1, 2, 3 NAND gates. So here you'll get A plus B. Just observe, you got here A bar and then B bar. Then this gives A bar, B bar, whole bar. We know De Morgan's law. Split the bar, change the sign. Hope you know this trick. Split the bar, change the sign. So when you split the bar, get cancelled, and it is A plus B, right? And then XOR gate. You just go through this 2 to 3 times, then it will be easy for you to get, memorize. This is so simple. We know this is 1, 2 gates, 3 gates. Here you need 4 gates, right? And yeah, that's it. And here you need 5 gates. This is also very simple, guys. This say A and this B and this and then this. Then join these two. Then join this output with the previous output. That's it. And we know that it's A plus B here and it's A XNOR B here, right? Then observe carefully. You use 2 NAND gates here. We know that we require 2 NOR gates here. So means 3 NOR gates here to implement AND gate. So just draw the same things but replace the NAND gate using NOR gate. That's it. Quite simple, right? And then this and then that's it. What it gives, I've forgotten. Oh my god. Okay, sorry. And then this also same. What you did here, do the same here, but replace NAND gate using NOR gate. A, B, and then again A plus B. That's it. Here also We know that this 4 comes here, this 5 gates comes here. So same, this implement this gate, just replace NAND with NOR. Same. Observe carefully that I am doing the same thing but just replacing the gates. And joining these two and joining this output with the previous output. That's it. And you'll get, obviously you'll get, you can check all the A, B inputs from here and then you can check, you'll get this. You'll definitely get this. Then here you implement same this here. Just change the gates. That's it. Right. Oh, I'm sorry. This is not gate, right? Sorry. My bad. Yeah. A, B. And then NAND gate, of course, this is so simple. The gate itself, and here also the gate itself. And this, you observe carefully. Here we implemented OR gate. You just add one more NOT gate here, then you'll get the NOR gate, right? Simple, isn't it? That's it. You can check the output. And here also you have AND gate here. You just add one more NOT gate here, then you'll get the NAND gate here. Easy, right? And you remember this trick, 1 1 then 4 4, right? Yeah, simple, isn't it? Yeah, that's it, guys.